Hello students, I hope all of you are very fit and fine. Students, in this video we are going to talk about the exercise questions of matter in our surroundings chapter. Okay, this was the first chapter of your science book, that is from the chemistry background. Okay, I have done all the theoretical part in the previous videos, so in this video we are going to start the exercise questions with answers. Okay, so the first question of your exercise is convert the temperature in Celsius scale. Number one, 300 degree Kelvin. That means we have to convert this 300 degree Kelvin temperature into degree centigrade. Okay, students, we know that degree centigrade is equal to what? Is equal to Kelvin minus 273, or Kelvin is equal to degree centigrade plus 273. We know this because this is the relation, we knew it from our previous video where we were established this relation, that the degree centigrade and the Kelvin scale. Okay, so degree centigrade is equal to Kelvin minus 273 and Kelvin is equal to degree centigrade plus 273 degree. So 273. Now, as in the question it is given that 300 Kelvin, that means in this relation degree centigrade is equal to 300 minus 273, that is equal to 27 degree centigrade. Okay, that is 27 degree centigrade. That means 300 Kelvin is equal to 27 degree centigrade. Okay, so the next part is, the next question 1b, it is given 573 Kelvin. Again, degree centigrade is equal to Kelvin minus 273, that is 573 minus 273, that is 300. So 573 Kelvin means 300 degree centigrade. Is it clear? So this was question number 1 and question number 2. So in the question number 1 we had 300 Kelvin, and in the question number 2 we have 573 Kelvin. Okay, done. So now let's move to the question number 2. In the question number 2, it is convert the following temperatures into the Kelvin scale. Number 1, 2a, 25 degree centigrade, and b, 373 degree centigrade. Okay, no problem with that. So now in the degree centigrade it is given, we have to convert it into Kelvin, and we know degree centigrade is equal to Kelvin minus 273, or Kelvin is equal to degree centigrade plus 273. That means in the first question 25 degree centigrade is given, so 25 plus 273, that is 298 Kelvin. So 25 degree centigrade is equal to 298 Kelvin, and in the same order here it will follow, that is Kelvin is equal to degree centigrade plus 273, that is 373 plus 273, total 646 Kelvin. That means 373 degree centigrade is equal to 646 Kelvin. Okay, so the question number 2 is done right now. So now let's move to the question number 3. Okay, the question number 3 is give reasons for the following observation. Number A, question 3a, naphthalene balls, that is naphthalene balls disappear with time without leaving any solid. Question is naphthalene balls disappear with time without leaving any solid. Okay, so let's move to the answer. We know what is sublimation. What is sublimation? Sublimation means the process by which a solid matter is converted into gaseous matter, a solid matter is converted into gaseous matter without passing through the liquid state, directly from solid to gas. In case of naphthalene balls, okay, the temperature required for the sublimation process is very low. That means easily in the room temperature, at the room temperature means generally 25 degrees centigrade we are considering. Generally in room temperature, at room temperature, naphthalene balls is starting to sublimate. That means these solid naphthalene balls are going to be converted into gaseous particle without passing through the liquid state of matter. Okay, that is why when we keep some naphthalene balls at our room temperature, after a certain moment that temperature is absorbed by the naphthalene balls and it will convert it into gaseous state without passing through the liquid state. That means it sublimates. That is why the question here is given, that why naphthalene balls disappear with time without leaving any solid. That is the main reason, that solid particle is going to be a gaseous particle. That means the sublimation process is processing here and without passing through the liquid state. Is it clear? So question number 3b, we can get the smell of perfume sitting several meters away. Yes, this is our real life application where you can smell, or you can get the smell of any perfume at the sitting several meters away. Okay, now the question is why we are getting the smell when we are sitting several meters away from the source of the perfume. Okay, so just write it. At first, perfumes vaporize very fast. And its vapor diffuse into air easily. That means perfume, when it is kept in a bottle, okay, or in a container, it is in the liquid state. Okay, it is in the vapor state or liquid state. Okay, whatever. But when it is outside of the container, that water particle, that aqueous particle or the gaseous particle is turned into vapor particle. Okay, vapor particle, and that vapor particle, we know in the gaseous medium there is the particles, the difference between the particles or the gap between the particles is very far away from each other, and the particle of a matter has a tendency to move from one side to another side. So this vapor particle is also a type of gaseous particle, so it will move from one part to another part, and that is why we are getting the smell sitting several meters away from the source of the perfume. Okay, so this was the first three major question, and the next question is question number 4. That is, arrange the following in increasing order of forces of attraction. We have water, this is question number 4, water, sugar and oxygen. The question is increasing order of attraction forces. Okay, we know in case of solid particle or solid matter, the attraction between the particles is maximum. In case of solid, here sugar is a solid particle. It will have maximum attraction force. Okay, in case of water, it is liquid particle, we know. Okay, so we know solid is having maximum attraction force of particle. In case of liquid, it is having less than the solid particle. Okay, and in case of gas, the attraction between the gaseous particle is very low. So here we are asked to arrange the order in increasing order. Okay, arrange the particles or matter in a increasing order. That means low to high, increasing. Okay, gradually increasing. Okay, so at first gas, we know, is less than liquid, is less than solid. This is the arrangement series. That means where you can definitely say that the force of attraction between the particles of gaseous particle is less than the liquid particle, is less than the solid particle. So the correct order will be like this: oxygen, because it is a gaseous particle; liquid, that means water; and after that sugar, because this is a solid particle. Okay, so students, in this video you are getting first four questions of your exercise, and in the next video we will discuss the latter, that means the question number 5, 6, 7 and 8 and the remaining parts. Okay, so hope you are liking it, and just copy all the things in your own copy. Okay, so stay home and stay safe. Thank you so much.